Alright, just an improvised recording to have you going a bit with the labs. This sort of relates to the second lab, the lab we call number 1. And we are going to play around a little bit with Linux here and look a little bit how we load files and run them in the Cadence environment. So I've started up an Emacs buffer on the side here and opened up also the Cadence window, the command interpreter window, the CIW, which is where you paste your code and read the results of the code, etc. And then an Emacs buffer with already uses Lisp syntax, as Lisp is the default language of Emacs. In Cadence it's called skill, and it has some sort of abbreviation which I don't know, but it's essentially Lisp dialect of some kind with add-ons to it, quite a few add-ons. We are just going to take a little quick look at how you load a file in your CIW. So first I can save this file, something in my work area, so Scriptic, and then the file .il, and il is the typical extension for skill or Lisp. And here I then add the commands, and skill or Lisp is well known for the parentheses. You have differentiating the clauses and so, yeah, more or less everything with parentheses of different kinds. So if I want to type, for example, a command like this that prints the text to the output, and parentheses are separating them or specifying them. Printf works as well, so it supports both syntaxes here. Now if I want to run these commands, I could either just copy them and paste them into my CIW and execute, and I obviously get hello world. Cadence or skill in this particular case also replies with T here, as in true. It uses T for true and nil for false as two Boolean logic indicators then. I can type for loops for m from 1 to 10, and then I want to execute some series of commands inside this for loop. I might want to print something. And here I can convert my integer, because this is an integer being swept. So maybe I want to say that this is iteration $d for m, for example, and then I can run this for loop, and yeah, then we get all the text here. This is iteration 1, 2, 3, 4, blah blah, all the way up to 10. I can start printing like this to get a new line, and then I get the printouts in this way. I can also execute commands directly in the CIW, so I could, for example, catch what m is. It's not defined because it was inside the loop, but I can define m equal to 2, and then I can also type my for loop here, m1 to 8, and then printf d new line m, for example, to print them out. Okay, if I want to load the file itself and execute it, I can do that with the loadi command. Loadi, and then specify the file name and where it is located. In this particular case, it always searches for the current directory first, which is your work area. we can add that as a comment to the file to remember that. Alright, then we can do some other clever tricks to speed up the coding and debugging of it. We can already see in Cadence, if we in the daisy flow press F12 here, we get a list of all the bind keys that are defined. We can, for example, find F12 here, which prints the bind keys. That was the one I just pressed here. And we can also check the Control L, which is a handy command. It's tied to the command LTF, load the file. So if I just make sure to redefine LTF in this script to load itself, then I'm pretty up to speed. So I define a function that redefines LTF to load this particular file. Okay. So I can just define function LTF space no arguments, and then I take load I the file dot il like this. And then the first time we had to load this statement into our CIW like this, and now I have tied the LTF command to the bind key previously, and I can just press Control L and then it loads the command. This is some other command, probably still kept in the buffer here. Ignore that, at least it performs the action we want. Right, so it's handy to just leave this somewhere in your script at the top, for example, as part of your development. So you always have this tying here to the bind key. We can leave this stuff here. We can do other interesting things. Obviously the whole world opens up here for script development, but there are a lot of useful commands to search for in the help in Cadence. There's a separate skill file, PDF file that focuses on the skill language, so I recommend you to download or read that document. One can, for example, convert things to string. For example, there's a command called sprintfill, so sprintf nil 3. So this converts the number 3 to a string, 3 as a string, and then I want to print that. So then I print it with the printf command, 3 as a string, and then we can execute that. Control L, and we get 3 here as a string. So pretty handy. And there are plenty of other things here. So next step is to look at the schematic. Right, so schematic. We have an operational amplifier, or at least a differential stage here, which it's not sized per se, but it has the component that we are interested in. And now I would like to show the way the database is set up in Cadence, and how we can access them through skill. So every single cell, every single object, everything is sort of saved in a database in a not same format, but at least with the same sort of approach to saving the objects. So current source is an object with certain properties, and a transistor is an object with certain properties, etc., etc. So for example, if I would like to list all the components in my cell view, how can I do that? There is a quite practical command, I get current window. So HI is for human interface. I can capture, I can get my current window CW equal to I get current window. I can get, well, we can actually execute that. Control L and then go to our CIW and see what CW is. A window is an object that I get from my script. I can investigate what's underneath, so I can type CV arrow, which is a get queue command. We can come back to that, but that gives me then a list of all the objects inside the object window too. And if we scroll up here, we see, for example, that you have something called a cell view, which we are interested in. So I can capture that, CV equal to CW cell view, and Cadence is caps sensitive, so beware of that. And now we can just continue here and see it's CV, Control L to execute CV. Okay, now I did the same sort of operation here. CV, CV question mark. Okay, now I have it. Oh, sorry. Let's redo that. So there we go. CV. So now I get all the objects associated with the cell view. So here we can find the other things that we recognize: library name, cell name, blah 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 name, and all these things associated with a single cell view. I can also see I have all the instances, for example, and yeah, a lot of different pointers here to different shapes, nets, signals, ports, blah blah blah, everything you could imagine that you need to describe a cell view then. The CV with 2 question marks is quite handy, because that prints out also the next level in the database. You get all the shapes, you see there are quite many. So you not only get the name of the object, but also the sub objects inside that object. So now I can quite easily find, for example, inst equal the CV instances. We can execute that for the fun of it. And now I have instances, and that gives me a list of all these guys. And I can, the same way here, I can, if I do this, it won't work. I will just get the same with a hyphen and larger than, like this arrow. I can do insts and then do a curly arrow, and then it jumps inside and picks the information for all of these different components inside my list. So this is the skill list array or vector or whatever you want to call it. So if I do curly arrow, I will get information about all the objects inside my instance list here. And now I can do cool things. Maybe I want to do list all the instances. So I can do for each instance in instances, and I might want to print let's do info %s for inst libname, for example. So that's a pretty simple way of just picking all the instances from the cell view, which is picked from the window, and then I do a for each loop across all the instances and pick out the inst for that one. And then I can use the arrow approach here to get the libname for that particular instance. So let's see if that works. And I probably forgot a line break. Yeah, so let's do this. And here I get my information. So I have all the different library names for certain cells. And obviously I could just do if inst libname equal inst libname, say Daisy. Then I want to print, or if not, I'll print if not there. Something like that. Hopefully that works. Ah, forgot the standard new line character. Okay, there we are. So one was in the Daisy library, single one, and then all the others were from some other library. We can do the same test with GPDK 045, for example, and try that. Okay, now I have 1, 2, 3, 4, 5, 6 components from the GPDK library. And instead of instance library name, since I already know we're inside this library, I might as well just print the cell name like this. Control L. Okay, and mosses, p mosses. Maybe I'm interested in the has width, and this might not work now if we get the numerical value. Let's try inst w. Yeah, it worked pretty well. So it was interpreted as a text. So I tried to print the width as a string here, and it seemed to work. So we get pmos1v has a width of 40, 120, and then some sort of expression, 8, 10, 10, etc. So I have a pretty simple way of calculating all of them. You can obviously do the same with the length L, and then L. Control L. Okay, there we had an issue with the format. So it probably interprets that as something else. So one can sometimes trick it by doing a list notation, and then it can print all of them. And I realized my error was probably that I didn't use S for string rather than anything else in this particular case. Right, so pmos1 has width 40 and length 60, etc. So the parsing can be quite easily done here. So this parses through all instances, check if they belong to a certain library, prints information about them, etc., etc. And also here you could, for example, W and L, and take the area and report total area or something. Something like that, perhaps. So it's pretty simple. Just an idea of what you can do, and especially this Control L button is very practical, so you can just quite easily update your script on one side and just, you know, easily go to your window here and just execute Control L, and you see in the background it updates. Oops, wrong button. And then it updates. Then it updates the text in the background here. So very handy. There are also ways to take this particular text if you want to, and you can create the text label in the output here. So for example, which I've done with commands like Control 2 if you have the simulator up and running, which we don't at the moment. But at least some inspiration for you. Emacs, Lisp and skill language, and the coupling to the Control L to be able to access the script easily from your environment was the topic for today.